Hey everyone! In this video we are going to be solving exact answers using completing the square. So we've been practicing using completing the square to turn things into vertex form. This time we're going to solve for exact values. So we have 3 equals x squared plus 10x plus 7, and we want to get those x's so that we have a perfect square. We're going to subtract 7 from both sides. This is different from just chucking that c value to the side, because this time we actually have somewhere to put it. But we subtract 7 from both sides. Now it's on the other side. We have a negative 4. We still need to make that perfect square. So I'm going to write this as negative 4 plus a blank equals x squared plus 10x plus a blank. Now, if you've watched any of these before, I use the blanks for the perfect squares because we have to decide what to add. What we add is always going to be half of what's in front of the x squared. Half of the 10 is 5, squared is 25. But whatever you add to one side, we have to add to the other side. And when you're doing this in vertex form, you add it and subtract it. This time we have 2 sides to play with. So if you add a 25 on the right, you can add a 25 on the left. The left-hand side cleans up. The right-hand side is a perfect square. It just becomes x plus 5 squared. We made it a perfect square, but we can write it as a perfect square. We're one step closer to getting to x. We're going to have to take the square root of both sides. When we introduce a square root, when we're doing algebra, we have to have that plus or minus because there's 2 possible answers. So we have plus or minus square root of 21 equals x plus 5. We're almost there. We can check that 21 to see if it contains any perfect squares, if it's simplifiable. It doesn't. The x comes over. Negative 5 plus or minus the square root of 21 equals x. And that is our exact value. Now, if you wanted decimals, you could have used a quadratic formula. You could have graphed this and gotten the x-intercepts. There's lots of ways to get the decimals. When you're using completing the square method, we're really trying to get that exact value. We want those radicals. And when they don't clean up so nicely, we're going to do an example here where we have to do quite a bit more cleaning at the end. In this second example, we now have a number in front of our x squared. So we have 8 equals 2x squared plus 12x plus 13. We're still going to complete the square, but remember that we have 2 sides to play with. So instead of just chucking things over, we're going to chuck them to the left. So we subtract both sides by 13. We get negative 5 equals 2x squared plus 12x. We don't have to factor out the 2. We don't have to factor out the 2 because we can actually divide by 2 and get rid of it. So we can just divide everything by 2 and we get negative 5 over 2, no decimals, fractions, we're going for exact values, equals x squared plus 6x. I'm going to rewrite this up top, but if you've gotten this far, this is just a regular completing the square problem like we did above. This one's just going to have to be a little more simplified. I write that blank on both sides because whatever we decide to add, we have to add on both sides. It's always half of the number in front of the x squared. Half of 6 is 3. 3 squared is 9, so we're going to add on a 9. Because we added a 9 on the right, we have to add a 9 on the left. See, we got this. In order to add those terms on the left, though, we're going to need a common denominator. This math isn't tricky, it's just going to get a little bit busy. So we have a negative 5 over 2 plus, to get that common denominator, we have to double that 9 and put it over 2. So an 18 over 2. The right-hand side, that's a perfect square. We can clean that right up because that's just x plus 3 squared. Okay, right-hand side done. The left-hand side, the negative 5 plus the 18 all over 2 just becomes a 13 over 2. That equals our perfect square, x plus 3 squared. We're going to get that x out of those brackets. To do that, we're going to take the square root of both sides. So yeah, we're going to take the square root of that fraction. We introduce the plus or minus. The square root of 13 over 2 is equal to x plus 3. All right, we need to get rid of that 3. We have to bring it over to the other side. Now I'm going to write this x equals, but it's still just bringing that 3 over to the other side. The 3 brought over becomes a negative 3 plus or minus the square root of 13 over 2. but we don't like radicals in a denominator. We can't have that root 13 with a 2 on the bottom. We have got to clean that up. So we're going to break that radical apart, and this is going to become x equals -3 plus or minus a root 13 over a root 2. Okay, you can break fractions that are inside radicals apart just like that. Now that we have a root 2 on the bottom, you've done this before, we can get rid of that root 2 on the bottom by multiplying both the top and the bottom by root 2. We'll bring this down. Yeah, it's a little bit of cleanup, but we can do this. The -3 plus or minus. We have a root 13 multiplied by a root 2. That cleans up and it becomes root 26. All over, we have a root 2 times a root 2. That's just a 2. That 26 doesn't have any perfect squares, but we still need to get a common denominator with that -3 and the root 26. We're going to have to double the -3 to make it a -6 plus or minus the root of 26 all over 2. I could have written that as 2 steps as -6 over 2 plus or minus root 26 over 2, but we just combine that to 1. Box our answer. That is an exact value. When you are cleaning these up, watch to make sure that you don't have any radicals in the denominators. Watch to make sure that your radical does not contain a perfect square. And always check the terms that you're adding, because if there's any chance to add them, you have to get a common denominator and add them together. These were 2 examples of how to use the completing the square method to get exact values. I hope that this was helpful for you. If you have any questions, please feel free to leave them in the comments below, and I'll be looking forward to seeing you next time.